So this week we're going to do an experiment on Atwood Machine. The setup is following. Across the pulley here we have a thread, and then on the end of this thread we have two mass hangers. Each mass hanger has 100 grams on it. Then one has 10 grams and another one has two 5-gram masses. So the total mass on each of these right now is 115 grams. So right now they're balanced, so the system is at equilibrium. And then furthermore, we use a photo gate to record the moving of this smart pulley. Photo gate is connected then to the universal interface, which is connected to the computer to collect the data. So the mechanics of this experiment is really simple. Basically, what you will do is you will transfer 2 grams from this mass here to the other side. So now we are creating mass difference, and then this mass M2 is heavier, so it will fall down. So basically what you will do, you will log in on your computer to the student account and then open the Atwood Machine experiment. Then you're going to record the acceleration of the mass M2 and M1 as they move up and down. The most important thing here to do is you're going to work as a group. So one person is going to run computer, another person is going to run experiment. The second thing you need to remember is before this mass here, M2, reaches the ground, you need to stop the movement. So I'll show you on one example how to take the data. Okay, let's go. On 3, 1, 2, 3. And you're going to stop it here. So before the mass M2 reaches the ground, you're going to stop mass M1. Then you're going to repeat the same thing 5 times. So again, bring this to the top. On 3, you should start recording, and then on stop, you should stop recording the data on the computer. So on 1, 2, 3. Stop, and then make sure you catch this mass before the mass 2 reaches the ground. So what you will do, you will repeat same thing 5 times. So you'll have 5 runs on your computer. So after you recorded acceleration 5 times for the first mass transfer, you will repeat the same process, transferring 2 by 2 grams until you transfer all of these blue masses to the second mass hanger. Every time you're going to take the data 5 times, and then you're going to find the average acceleration, and then you will plot the average acceleration versus the change in mass, and then calculate the gravitational acceleration and calculate the friction force between the thread and the pulley here. So important information that you need is given on this information sheet. You have 200 gram masses, 1 10-gram mass, and you have 5 2-gram masses. You can see here how setup should look like. The R, outer radius of the pulley, is given. M prime here is equivalent to MP in your lab manual. And also you have given D, which is the diameter of the bearing of the pulley. You will use this D to calculate a small r that you will use in your calculations furthermore. Once you're done taking the data, you can move on to data analysis. In the next part, I will record the screen of the computer to show you how to accurately analyze the data and finish all your calculations.
Now I will show you how to analyze the data that you just collected. So if you click here, on this arrow, you will see that you collected 25 total runs. What you did is you transferred 2 grams from M1 to M2, and then you ran the program 5 times. Then you transferred another 2 grams and you repeated the same thing 5 times. So you had total 5 mass transfers, 5 runs each. In this video, I will only show you how to analyze the first dataset. You're going to click here, select run 1, run 2, 3, 4, and 5. Then you're going to highlight run number 1. Once the dataset is highlighted, you see that the color for that dataset is brighter than the rest of them. Also notice here that I didn't stop recording the data on time, so I will have to neglect these couple of points. In order to neglect these couple of data points, I am going to select data points up to this point by clicking here on the data highlighter, and then I'm going to move this box, and then I'm going to enlarge it so I highlight the points that I want to analyze. Then I'm going to click here on linear fit. Next, highlight dataset number 2. You stopped on time, so just choose linear fit. Run number 3. Also, you stopped recording the data on time, so it's good. I'm just going to click here and choose linear fit. Highlight dataset number 4. Repeat the same thing. And then lastly, for dataset number 5, I also have a couple of points that I need to neglect. So I'm going to click here on the data highlighter, move the square here, and then I'm going to enlarge this square. So this way I selected only data points that I want to analyze, and then choose linear fit. Okay, now you can move these squares a little bit around, so they're easy to read once you print a graph. Okay, now we are set. Since you're plotting linear speed versus the time, the slope of these curves will represent your acceleration. You will record these slopes to the table in your laboratory manual. The next step is to label this graph. Just go ahead and click on this letter A. Then this box will pop up here. You can move it out of the way, and then you can also increase the size of the box so you can see what's written inside. Basically what you need to write is your name and your lab partner's name. I'm gonna write my name twice because I did this on my own. And then you need to label this graph somehow that will help you differentiate between the 5 graphs that you will print out. I suggest you go ahead and write down the mass difference between M2 and M1. So you can type delta M and the value. So for the first data set, your mass difference is 4 grams, so it's going to be 0.004 kilograms. Okay, so now you're ready to print a graph. Click here on File, click on Print Preview, and then you're going to choose your graph to come out as a landscape, and then click on Print and choose the copy for you and your lab partner. Click Print here. For some reason, the printer does not communicate really fast with your computer, so you will need to wait for a minute or two for your graphs to come out. So now when you printed this graph, you're just going to go and deselect the first 5 runs. Notice that after you removed the first 5 curves, the label for your graph stayed here, so you will only need to go ahead and change the delta M value. And then you're going to select next 5 runs and repeat the same thing until you analyze all your data sets. Once you're done, you're going to close the program and log out of the student account. This is all when it comes to data analysis for this experiment.